So 3 days in a row, a dog owner tied his dog's 5-foot leash to a post outside a store while he ran into the store to get a drink. First of all, don't do that. Second of all, let's go. Each time the owner returned within minutes. The dog's movement each day is described here. So day 1, the dog walked around the entire time while waiting for its owner. Day 2, the dog walked around for the first minute and then laid down until its owner returned. Day 3, the dog tried to follow its owner into the store but was stopped by the leash. Then it started walking around the post in one direction. It kept walking until its leash was completely wound up on the post, and the dog stayed there until its owner's return. Each of these graphs represents the dog's distance. So they're telling us information here. It represents the distance from the post in feet as a function of time in seconds since the owner left. Okay. Then it asks us to identify which day each graph represents. So we got this dog, he's walking around, and there's different days that he's doing all these different stuff. Okay. So looking at each of the graph A, kind of describe what's going on. Just like in words. Don't try to relate it to one of the days. What's going on over here? Is it going up or down? It's going up and then kind of goes down, and then what happens here? Okay, so this is called constant. That's the word we use in math. Okay. All right, so we go up and then we go way down and then we kind of just like flatline, right? So which one of these days does that describe? Which one of these days does that describe? Day 2, why? Okay, so he laid down, so he was constant, right? So this is going to be day 2. Everybody get kind of how we did that? Okay. All right, let's look at graph B. What happened on graph B? He went super far away, and then he started getting closer and closer and closer back to the pole, right? So which one does that describe? Why day 3?
That wrapped around the pole. And then have to stay
Exactly. Okay, now graph C, dog went a little crazy. He got really far, then got close, then got far, and then got close. Okay, so he was moving around the entire time, right? So this guy is day 1. Does everybody see kind of how we related word problem to the graph? Okay. Not too bad, right? Okay. All right, so today we're going to talk about function notation. You have seen this since day 1 in 6th grade, okay? So function notation is a way of writing the outputs of a function that he's given a name to. If the function is named f and x is the input, then we have f of x that denotes the corresponding output. I know none of that made sense. Basically, what we're doing is we're saying, hey, we got a function, and here's the name. The name is f of x. That's all that's saying. Okay. So using graph A to answer the following question. So how far away was the dog from the post 60 seconds after the owner left? Okay, so let's look at this. On our graph, we have time in seconds for the x, and we have distance from the post in the y. So at 60 seconds, how far away was the dog? Okay, and we see that because that y value, right? Okay, so it was 4 feet away. The reason why I looked at 60 is because in my problem it says, hey, at 60 seconds, what was my y value? Okay. Now part B, how far away was the dog from the post when the owner left? So at what time would we be looking at for that guy? Not 60. So when did the owner leave? What time? Let's look at it this way. All right, so right here to right here. This is when the owner got back. So when did he leave? He left at 0. Okay, so this is when he left. Because remember, he tied him to the post and then he left, right? Okay, so the owner left at 0 seconds. Now, part C says the owner returned after 160 seconds. So at 160, how far away was the dog? So at 160, so looking at my X, what was my Y value? 4. That's right. So he was 4 feet from the post. Okay, now how many seconds passed before the dog reached the farthest point it could reach from the post? So how far away can the dog go? So we're looking at our Y values because that's our distance, right? 5 feet. Because remember, this one described, hey, he went as far as he possibly could, and then he went and laid down, right? So how far away can he go? 5 feet. So how many seconds passed before the dog reached that point? About 40, right? Biggest thing with word problems is kind of figuring out like what's going on in this scenario, right? We're talking about a dog, time is passing, and he's going farther away from the post and then getting closer, right? So there's just a lot going on. Now, number 2, it says, consider the statement. The dog was 2 feet away from the post after 80 seconds. Do you agree with this statement? How would we figure out if we agree with that statement? So the dog was 2 feet away after 80 seconds. So what should I do? Check the Y. So if I look at 2 feet, so let me get rid of some of these lines. If I look at 2 feet, when does that happen? Like at 5 or 10 seconds, right? Well, what about at 80 seconds? Where was he at? He was at 4 feet, right? So do you agree with this statement? No. So false statement. He was 4 feet away. So on number 3, it says approximately how much time had passed when the dog was 3.5 feet away from the post. 3.5 feet away. So looking at our distance, was it 35? Let's look. At 3.5, how much time has passed? 20. You could have also said probably like 50. That would have been okay too. Okay. So now let's actually like put this in math terms. But one way to talk about function precisely without wordy descriptions is by naming the function and using function notation. So it's almost like a nickname for the function. So suppose we gave the name to the function represented in graph A from the post and the time since the owner left as a function of f. So we're saying for graph A, this is now going to be called function f. Okay. To represent the distance of the function, distance of the dog from the post 60 seconds after the owner left, we could say f of 60. Okay, so going back over here, you remember how we said how far away was the dog from the post 60 seconds after the owner left? In math terms, we would just say f of 60, and we would put a question mark next to it. Does that make sense? So we took the English version and we put it in math terms. Okay, now what was the answer to part A? What was the answer to part A? 4 feet, right? So if I ask you, what is f of 60? You would tell me 4. Does that make sense? Yes, no? Okay. Now, the input is what we put inside the parentheses. So 60 is the input. The output is what you told me that it is. 4 is the output. Those are 2 words that you need to know. Input is what is inside of the parentheses. Output is what did you produce. Okay, and again, when we looked at this, we said, okay, at time 60, what was my y value? So at time 60, what was my y? Table. So it says, use function notation to complete the table. So the distance from the post 60 seconds after the owner left. We've already established that this is f of 60. Right? So we're looking at 60 seconds. Where's the function at? Now, distance from post when the owner left. When did the owner leave? At what time? 0 seconds. So what are we going to plug in? Let's try it again. Right. So that would be the output. That's what it equals at the end. But we want to write it as function notation. So we're going to say f of some number, right? Okay, so how would I write C? The distance from post 150 seconds after owner left. So looking at part A, we said f of 60. Looking at part B, we said f of 0. So what is part C going to be? F of 150. Perfect. Now, when we look at 150, what did that equal? 4. This is just a fancy way of taking words and putting it in a short notation. That is all this is. Okay, so now we're going to kind of do this backward. We're going to describe what this means. Okay, I'm going to help you on the first one. So it says f of 15. So this means the distance from post 15 seconds after owner left. Do you think you can do B? Okay, try that one. All right, so on B, what'd you get? Okay. Distance from post, 100 seconds after owner left, right? Perfect. Makes sense? Okay, now they're trying to trick you up on this last part, but don't let them. You're going to write the exact same thing, but instead of a number, we're going to say T. What does T represent? Time, right? Okay, so distance from post, T seconds after owner left. So this is just a way to say, hey, we got a function and we're dealing with time and we're dealing with distance. That's all it is. So the equation f of 35 can be interpreted to mean 35 seconds after the dog owner left, the dog was 5 feet from the post. All right, so does everybody see where we get these numbers from? We got 35 and we got 5. Okay, notice how 35 is the seconds because that's what we plugged in here. And then 5 was the distance because that's what the output is. Okay, so on this first one, this means that we have 50 seconds after the dog owner left. the dog was how far? 3.7 feet from the post. Okay, so I got T seconds after dog owner left. The dog was 3.5 feet from the post. Okay. On the last one, this one uses two variables, but what this is going to say is T seconds after dog owner left, the dog was D feet from post. You got that? Good. Let me clarify. This one is going to be the one that you see most often. It's going to say something along the lines of the word interpret. Okay, you're going to see this word, and they're going to ask you to basically write out what the scenario is talking about. Okay, so this is really kind of where we want to be. All right. So you have that other worksheet, okay, and it's exactly what we just did, just a little bit more practice. Okay, I want you to take about 10-ish minutes, and we're going to work on that. Okay, you should be able to at least finish 1, 2, and 3. Okay, all right, so go ahead, take a little bit of time. If you want to work with a neighbor, that's fine. Or if you want to check your work with each other, that's fine. Make sure that you pay attention to, make sure that you actually pay attention to the graphs. Because if you don't pay attention to the graphs, that can mess you up a little bit. Those are different graphs, okay? So go ahead and take a couple minutes. That is what you're working on.